Hi, I'm Nolan. This is week 2, 2025. This is like my 7th take, so we're just going to go right into it. Here's object 1. I'm combining values in order to make object 1. And then my question is asking, what will the type of data be? And what you really have to think of for this question is, well, what is the most complex type of data that is being combined into this single object? And because that complexity will restrict the type of data that is output. It will go towards the most complex that is included. Now, in general, it won't go to the most complex of our simple vectors, at least, which is list, unless one of these is already a list, but none of them are. However, one of them is a character, which will mean that all of the rest of these will need to be coerced into a character. Now here I have listed out kind of all of the different common types that you might encounter, at least common vector types that you might encounter in R. They are listed currently in the hierarchy of complexity. And so you're just always basically going down on this list unless the user is specifying to go the other direction. So those are all going to be our implicit coercion directions heading down. But these are going to be coerced into a character because, well, it's more complex than a double or numeric type data, which is what this 1, 2, and 3 are. And please note, they're not actually integers. You have to have that capital L next to them to make them an integer. But that's why they're going to go into a character. It needs to be stored in memory in the same way. And this concept is going to come up over and over and over. So let's just go to the next question, and that will make more sense. And this next question, I'm giving you kind of like the output of a series of different test codes that serve as an example of how coercion might take place. Now, these aren't like really realistic pieces of code. I'm never just manually sticking together these values and just wanting to turn them into logical, but they do represent how I might be running code and like kind of just writing stuff on the fly in order to experiment and understand how a process does occur. So for example, if I want to know what happens if a student, for a question I'm expecting to be able to be coerced into logic, gives me something strange, which y'all will do because we're humans and we don't really follow instructions very well all the time. And I want to know what's going to happen, I would run these types of experiments. And in this one, we can see that a student, let's get out of that metaphor, that this vector is going to end up including the letter A. Because this C function, is going to try and combine all of these numbers with the letter A, it is going to coerce them all into character values, which is going to contrast to this one, which will remain numeric, aka double values. When they then get converted into logical, it turns out you're going to have to use a different set of instructions. So like under the hood, this as.logical has to do a process. And the process from a character to a logic is a different process than a number to a logic. With one of those not working, that object 2 does not successfully get coerced into true and false values. And that's just because it's coming from the numeral, big quotes is what I need my video on this one, the quoted 0 versus the actual quantity 0. The quantity 0 can be coerced into trues and falses. The quantity 0.5, turns out anything that's not 0 gets coerced into true. Anything that is 0 gets coerced into false. But the letters, unless the letters are literally TRUE, they do not, or FALSE, they do not get coerced into true or false. That's the main thing. So this question is first asking, what's the function that must complete first? This is me trying to point out like, hey, you need to pay attention to the order of operations here. It's the C. The C has to happen first because the C has to have completed. And first of all, we can see the parentheses. The C has to have completed before the as.logical can occur. And then the as.logical has to occur before the assignment can occur. Additionally, this line 4, all of these has to occur before anything on line 5 can occur. But the answer here being C, because that's the first one that needs to occur in line 4. Next question, it asks, same example, What's the actual question? Look at these following conclusions and determine what is true. And this is me just more trying to get you to kind of go through this concept of, in data science and in like programming in general, we can just do experiments. We can just sit there and we can tinker and we can explore and we can then look at our results and draw conclusions. And then, we modify our behaviors. It's computer science. It's data science. It's allowing you to do science on data. I get excited about this, and I hope you do too. It's kind of a fun puzzle sometimes. So here I'm looking at these lines of code, trying to figure out why one did not work and one worked really well. And what I can conclude is what we discussed before, is that this becomes a character value. And it turns out that going from character values to logical values for these specific character values does not work. That the character value 0 does not coerce into true or false, whereas the number 0 does. And so I could then go through my choices down here and I could be like, all right, the output of C can't be coerced into logical values. Well, that's not true because that happened right here. The number 0 cannot be coerced into a logical value. Again, not true. That happened right here. The character 0 cannot be coerced into a logical value. The character 1, the character A, cannot be coerced into a logical value. That is the conclusion from this process. And that is legitimately a conclusion I've needed to draw in the past because that's just an important thing for me to know. It's hard to look all these things up in textbooks. The much easier answer, textbooks, as if there's a good textbook for this. There's manuals and documentation, but in the real world, you just do the experiments and you find it out yourself. That's why this is beautiful. Anyways, moving past my philosophy. Next question. Use the below output in conjunction with the prior example to extrapolate what the values of object 4 will be. So we just learned that from a character to a logical does not work. But we did also learn that from a numeric to a logical does work. This one is then combining those. I even give you an example just because I'm very nice. And I want to prove to you that I can coerce these into numerics after they've been combined. So for example here, if I create a character value, character vector with 2 character values, there it is, and then I coerce that into an as.numeric, I get 2 and missing. If we apply that same concept to this 18 through 20 line of code, this all becomes a character vector. 1, 2, 3, 4, 5. Length 5 character vector containing the 0, those quotes on that, quote 0.5, and so on through A. But then once I convert it into numeric, I would have 0, the number, so 0, 0.5, I guess, 1 and 1.5. This is weird. And missing. So that A wouldn't make it through that coercion. So this would end up becoming missing. If I then called as.logical, I would finally get false, true, 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 missing still, because that as.numeric had made that missing before. It's going to remain missing. And so this is legitimately something I might use in my real code. If I am trying to go through people's answers and actually like pull out which ones could legitimately be coerced into a number and which ones can then be used to draw certain conclusions. So that's the as.logical, me drawing conclusions. That is a legitimate piece of code that I might use, but I would need to understand it. And that's the kind of point of this question. You need to be able to understand things like this. So in the end, 0 becomes false. All the other numbers become true. And then A becomes missing. So there it is. About the order of operations. This one, I don't know if it's a good question. I don't hate it. This is more of a definition question than anything. But let's just look at it. So I can look at me printing off object 6. So that's me running this line 46. Then I run line 47, that produces this. And then I run line 48 and it produces this. So on line 46, that's just me printing the object. And when I print it, I can see that it's a grid. Now I personally I know the difference between how a data frame prints and how a matrix prints. So I could actually look at this and know immediately what I'm looking at. I would never expect you to have that level of understanding. You're just starting out, and it's pretty subtle. But in the end, I know it's a grid, so I'm pretty confident it is either a matrix or a data frame. So I think all of us would be able to draw that. Those are our two-dimensional objects that we've talked about in this class. There's other classes of two-dimensional objects, but those are the big two. I then call summary information on this, and it's actually giving me different information for each of the columns. So we can see like this first column is a logical column, some trues and falses values. The second one is clearly some sort of number. Third one, some sort of number. I think that one might be an integer. Yeah, that's an integer. I can see it right there. This one's numeric. This one is a factor vector. Factor vectors are weird. It's where we have basically a separate piece of information that makes some integers stand for certain categories. And finally, we have the fifth column, which is just a character vector. I then show the output of structure function. Beautiful function, great for exploring the structure of data. And it's much more explicit here. We have a logical column, integer column, numeric column, aka double, factor column, and a character column. Okay, the fact that these are all different types of data, this allows me to distinguish between what I first hypothesized here, that a matrix can't store all these different types of data, because a matrix is essentially a single type of data just wrapped up into a rectangle. So it's just, you take a vector, you give it rows and columns, and that can align it into a grid. That's what a matrix is. A data frame is actually a list type data. And so a list contains different containers. So this would be container 1, container 2, container 3, container 4, container 5. And because they each can have their own properties on the inside, this allows a data frame to store multiple types of data. And so from that, I recognize that this is definitely a data frame. Those two combined. If I had only given you this bottom one, you would have not known for sure whether or not it was most likely, you would have not known for sure if it was a list or a data frame class object. But because I also showed it printed and showed it printing into a grid structure, then we can conclude that this is a data frame. There's layers there, but I think it helps. But that's the level I really expect you to know. A matrix, one type of data, prints off as a grid. Data frame, actually a list structure, but prints off as a grid. And that was it. So that there was more than one type of data. That's why it has to be not a matrix. Matrix can only conclude one. So I could say that there is more than one type of data, or I could say a matrix can only have one type of data. Kind of just the either side of the description. Now this next one is which of the below codes could replace the redacted code. So we are taking the head of iris. We're creating an object called IR head. It's going to still have all the same column names. It's just going to be much shorter. I'm then printing off IR head. It looks like this. I'm then printing off an extraction of IR head that's been redacted, and it's printing off this. Now, one thing to note, this is a data frame. This is not. This has changed its structure. It's the contents of this sepal width column, 3.5, 3.0, and so on. So there is some functions that allow us to get the contents of a container. The $, and the double square brackets, their whole job is to pull out the contents of a list type data's container. So $sign allows you to refer to it by name. Double square brackets allows you to refer to it by name or by the position. And that's exactly what's happening here. This one, you may not know for sure, and just because square brackets are so like multi-purpose, they have all these subtleties in how they act, but it turns out that if you use these square brackets with a comma, and it's only a single column, it does, by default at least, simplify that to the vector inside that column. I know that was a lot, and that's just kind of something you have to memorize. It's one of the more frustrating things about R, is that this does just simplify by default, for better and for worse. Like, once you you learn it and you incorporate that into your thoughts, it's fine, but it takes a bit to get there. Now, I think the hardest one of these, the rest of these don't really make sense. This would get the rows. This would then do like a secondary extraction that would make this shorter. This would just not work because this extraction no longer has rows and columns. So this would produce an error because this is looking for a two-dimensional structure thanks to this comma. Same exact situation with this one. This would produce an error talking about like it's not got enough dimensions because it's subsequent to this $sign. Same thing for this last one, not got the right number of dimensions. Also, the double square brackets only works for one column at a time anyways. This one is just, this one would work, but it's the same thing as this one where it is a subset. But this one is the main distractor. This example would actually return the right data, but in the wrong structure. It would return it as the whole container. And the reason why is a little bit complex. The reason why is that a list type object does have a one-dimensional structure. And that's because list type means it's stored in memory as a series of containers. And since it's a series, it's got a one-dimensional viewpoint. Sure, inside of each container, there's like more dimensions, but across that list type data, it can be considered to be a vector, and it is. If you call as.vector on a data frame, it will return true. Well, at least it used to. But anyways, so IR head, this is going to access that one-dimensional structure, which is just a series of containers, so it will return the second container. But that won't be simplified. Why does this one not simplify, but this one does? That's one of those frustrating things, is that this one simplifies. So whenever I'm using this two-dimensional extraction and I do narrow it down to a single column, it simplifies to a vector. Whereas for this one, if I do that exact same process, it does not simplify. It returns, in fact, the whole container itself. So it would just return a one-column data frame. Pretty tricky, right? Just kind of have to memorize that one. So this next one, I've already kind of answered based on my last section. The answer would be this one and this one. I think most students get this. Most students get this, and then they're confused why these don't work. That's usually more what it is. So the reason why these don't work is that after this extraction has occurred, it is now a vector. That's a one-dimensional object because it's the contents of that column. And so I can't then extract from it using a two-dimensional tool. This one and this one are both two-dimensional tools. The double square brackets just doesn't work this way. Double square brackets works only on list type data. After doing this extraction and getting back the contents of that column, it's a vector, not a list, a numeric vector, not a list type data. And so this tool doesn't work. Additionally, this tool is meant to only open up the container of one position at a time. And so even then it wouldn't work. So there's several layers of why this one doesn't work. This one's great though. Hopefully that helped. All right, next questions. This one's looking at some operators we've already seen. I don't know, I should probably take some of these looking ahead, but I think it makes it more exciting to think like, oh yeah, I got this, right? Because you do. It is somewhat intuitive. The details aren't, right? The details end up being unintuitive, but like the general concept usually can be kind of parsed out, and then you have to kind of know the details to get there. So, focus on getting both of those layers of this understanding. So first one, if I'm trying to just like say, all right, 1 through 5, I know that symbol now. We've seen colon a lot, and then I'm comparing it to the number 3. What should that return? Well, the result of a comparison like that should be logic. So the fact that my choices are all logical here should make sense. And then the question becomes, well, why is it less than equal symbol? Well, that's less than or equal to. And so if it's 1, 2, 3, those are all going to be true. And then 4 and 5, not less than or equal to 5. And so, oh, not that one, that one. True, 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 false, false. Most people get that one. We're going to continue to apply that same concept. So this one, inside the square brackets, turns out that just if you think through the order of operations, like, all right, this colon has been in parentheses, so that's got to complete before like this extraction can happen. But then before the extraction can happen, I first have to do this comparison. But before I can do the comparison, this 1.5 has to happen. And so you can usually break it down like this. I'm also not going to give you examples where you can't. And in real life, you just have to kind of explore the data and make sure you are coming to understand the order of operations sufficiently to know it's doing the analysis you want it to do. But that is typically how I am actually breaking down the code. I'm then doing experiments as needed if there's kind of like ties, or I'm just adding in parentheses like I've done here, although I do believe this parenthesis was actually necessary. I'm adding parentheses to ensure that things need to happen first. But anyways, that happens first. So 1 through 5, creating the vector 1 through 5. So that's a length 5 object of integer type, it turns out. It then compares that to the value 3. So that's going to give me true, true, false, false, false. Now that this is complete, this extraction can happen. And so from 1, 2, 3, 4, 5, I'm going to extract the true positions. So that's going to be 1 and 2. Because those were the ones that were less than 3. True, true, false, false, false. So true, true, false, false, false. Hopefully that makes sense. If not, break that back down or go into R and really just, start, I have to go on multiple screens for this, breaking it down into pieces. And you're just like, all right, what does this do? So I'm going to highlight that. Okay, that's just a integer vector. Then it does the comparison, true, true, false, false, false. On this outside, okay, it's the same vector before. And then once I run them together, it's true for 1, true for 2, false for 3, false for 4, false for 5. And that tends to make sense. Okay, this next one is just starting to string all of this together. Having a little twist here where the extraction inside these parentheses that first occurs is the letters object. Letters are the letters of the alphabet, as you might have guessed. And so this is going to be E, D, C, B, A in that order because it's 5 through 1. Okay, so if I'm then extracting using the result of the C function, this is going to be 1 and 3, length 1 or length 2 numeric vector. So I'm going to then be extracting out the first and third position of this. So the first position would be E, and the third position would be C. So that one's needlessly complicated, but it's more just trying to get you to wrap your head around how do we break these things down. And in the end, if you're not, you can come and test it, but just remember for our exam, you're going to need to be able to predict this based on just your understanding of the code. But if I ran this right here, I'd see E, D, C, B, A. If I ran this inside of here, I'd see it's the values 1 and 3. And so E and C are at positions 1 and 3. Next up is a similar concept, except here I'm just demonstrating that we don't always have to do like a fancy comparison like we've done here, or we don't have to use positions like we've done here. I could technically just manually specify falses and trues. Now, I will say that's not typical. That's not normally how I'm extracting things. I'm usually using position or name if I'm going to like manually combine values. To make logic, I'm usually doing some sort of analysis that results in logic. That's why I usually use logic in an extraction. But regardless, here I'm going to be extracting the third and the fifth position, third and fifth position. Not bad. Next one is why does IR head, what values does the following return given this extraction code? So here's IR head. It looks like this. In IR head, I'm first extracting sepal width. Okay, so it's this vector. It would no longer be a data frame at that point. I'm then doing a one-dimensional extraction. Excellent, that makes sense because I'm extracting from a one-dimensional set of data. But I'm extracting the based on the positions in petal width. So I look at petal width and I'm just like, all right, a vector resulting from petal width compared to 0.3 should return with false, 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 true, because that last is the only one that's greater than 0.3. So if I take these values, 3.5 and so on, and don't extract this one, 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 but do extract this last one, I would return just 3.9. I did see a decent number of students who just flipped it, and they just said the opposite, but that is how you would break that down. Figure out which ones are trues and which ones are falses, and then extract the corresponding true positions. One thing just to point out, that's why these always have to kind of match in length. If you don't, weird stuff starts to happen. We'll talk more about that weird stuff next week. In the end, in the previous question, I provided the square bracket with only a single argument and not two arguments. In other words, why use single square brackets and not this? All right, I gotta go fix that wording. But in the end, the reason why is that after extracting sepal width, the data is a vector and only has one dimension to extract from. Did I actually type all that right? Wow. Did not expect that. I pressed so many other buttons. I just didn't press them down far enough. Yeah. So the data is a vector and only one dimension. So this should not have a comma in it after this has occurred because it no longer has rows and columns. And that's it. Nice. I hope that helped. Definitely ask questions. This is a really important topic. Like, review this one until you understand it pretty deeply. But once you do, you really explain a lot of the more challenging concepts that occur later on as we start to string these together in more and more complex ways. But manipulating data is so much of my job, and it's what allows you to really start exploring and getting good with this tool set. So thank you for your attention and have a lovely day.